So in this tutorial we will see the rotation plus translation concept. So what we can see here that this is a mass m1 and this is a mass m2 and their center of mass is here somewhere, and the mass velocity of this mass is VA, and the mass B is VB, and the velocity of center of mass is VCM. So we will be calculating angular momentum around this point O. So let's check it out. So first I am going to calculate for this one. So this will be LO will be OA is the distance, or OA cross M1 VA. Now I want to suppose there are n particles here. Like this is only mass m1, so if there are n number of masses are there, so we are going to put the summation I is equal to 1 to n, and this OA will be ROA will be ROI. So ROI cross M, this is for one particle, this is for MI, ROI MI, and the this velocity will be for VI. This is for one particle. Now whatever velocity A, that is with respect to earth, is VA or VI, and the velocity of center of mass with respect to earth is VCM. Now velocity of A with respect to center of mass is equal to we can say or velocity of A instead ith particle with respect to center of mass is equal to velocity of I with respect to earth, and plus velocity of earth with respect to center of mass. So we can say here velocity of I with respect to earth, or A with respect to earth, is VI, and velocity of CM with respect to earth, so VCM. Now we are making it inverse of that, so we are using minus sign, that will be minus VC. So velocity of I, this is velocity of I with respect to CM, is VI, and so VI will be VI with respect to CM plus VCM. Now we are going to put this here, and for ROA, ROI, that will be ROA is equal to ROC plus CL. So we can make it ROC plus RO, we can make it OA or I, because we are talking about the ith particle, ith mass, we can say. So substituting this and this both here, ROI will be ROC plus ROI cross MI, and V will be VICM, VI with respect to CM, and plus VCM. Now calculating it, 1 to n, this one, then ROC cross MI EI with respect to CM plus I is equal to 1 to n ROC cross MI VCM plus I is equal to 1 to n R OI cross MI VI into C plus I is equal to 1 to n and yeah, ROI ROI cross MI VCM. So we can see ROI ROCMI. So first I am going to calculate this one, and this part will be like this. I is equal to 1 to n ROC cross MI VCM. So this would be the total mass into CM. So ROC cross P, sorry, M V CM. So this is VCM is the center of mass velocity, this is the center of mass, whole mass of the part, and this is OC. Now I'm going to see the other part. This you can say as the orbital angular momentum. Because this is ROC into MVCM. This is around the point O, angular momentum around the point O. Total mass is VCM is the center of mass velocity. So from center of mass, suppose if any body is having, suppose if it's a wheel or something like that, and the center of mass is having some velocity v, so around O it will be this distance, that's mv into m is the total mass into this. There might be some angular velocity also, so I will see it in the other part. So this is orbital angular momentum, and this ROI, no, okay, RCI. Okay, not OI, this is CI. I have to put it here, CI. This is also because ROC and CI. So this is CI, not OI. Here ROC, RCI. So this is RCI, yeah, RCI is distance, MI, and VI, velocity of this I with respect to center of mass. So this will be my spinning angular momentum. Because this R is from the center of mass, this MI and this velocity of ith particle with respect to center. We are going to calculate this later, and first I am going to see the first part. What will be the first part? So I am calculating this first part now. This is spinning angular momentum, and first one is orbital angular momentum. So this angular momentum is around the center of mass. Center of mass, because you can see here RCI, this is RCI, and this is MI, and this is VI with respect to center of mass. We'll see it later. First I'm going to calculate the first part. So this is okay, sigma I is equal to 1 to n ROC cross MI, and VI with respect to CM we can write it VI minus VCM from here, VI minus VCM. That will be sigma I is equal to 1 to n ROC cross MI VI minus sigma I is equal to 1 to n and ROC, yeah, ROC cross MIVC. So here this will summation will give me the total mass, so that will be ROC cross MVCM, and here also this will be like if we already know that M plus M, M1 plus M2 and so on, and VCM is equal to M1 V1 plus M2 V2. So this summation I is equal to 1 to n will give us the ROC cross this total mass, that is M, and this is VCM velocity. Now both are same, so it will be 0. So this part will become 0. Now let's check out the fourth part. That was that was I is equal to 1 to n RCI cross MI VCM. So this RCI was ROI minus OC. ROI CI, okay, ROI minus, from here I am calculating ROI minus ROC cross MI VCM. So this will be ROI summation cross MI VCM minus ROC cross MI VCM summation I is equal to 1 to n. So this will be the total mass. So this will become ROC cross M, summation of all VCM. And here it is like ROI. This is ROI and MI, and this VCM is constant. So we all know that M1 plus M2 and XCM is equal to M1 X1 plus M2 X2. So similar is the case here. This will give me R. This will be equivalent to, when we will do the summation of these nth particles, ROI into MI. So we can see here, from here, this will be ROC capital M, ROC cross capital M into this VCM is already here, so VCM. So we will do the, it will also become 0 when it will be, so it is, so this one and this one will become 0. So my angular momentum around O, this will be equal to orbital momentum, that is orbital angular momentum, plus spinning angular momentum. So this orbital angular momentum will be around this, the center of mass, orbital angular momentum, and the spinning angular momentum is around the center of mass. So this will be the around the center of mass. Spinning angular momentum, we can see it, that's R CI, you can see here R CI, this CI, MI VI CM, MI VI CM with respect to center of mass. And this one was for so suppose this was my wheel, and this was rotating with the angular velocity omega, angular velocity omega, and linear velocity v. So if I want to find, and this is the ground, so I want to find the angular momentum around O. So that will be, that's angular momentum around O will be, because here translation and rotation both are happening. So L around this O will be that's orbital angular momentum, or that's orbital angular momentum plus spinning angular momentum. So that will be orbital angular momentum plus L spinning angular momentum. So orbital angular momentum, as we checked it here, like orbital angular momentum will around O was the center of mass and velocity of center of mass into this. So that here the O will be like mv into mvr, because this is the distance around this. So mvr, and the linear angular moment spinning angular momentum, that will be around the center of mass, around this one, this, because we calculated here like the spinning angular momentum is RCI MI and V velocity of I with respect to CM. So velocity of this I with respect to center of mass, this is MI, and RCI is the distance with respect to center of mass. So that will be angular momentum, that is the spinning angular momentum. So what is my spinning angular momentum? That is I omega. So this is the angular momentum where I is the center of mass, where I with respect to center of mass. So mvr plus ICM omega will be the total angular momentum around this point O, if the disk is having both rotation and translation, rotation by angular velocity omega and linear velocity v. So this will be the orbital angular momentum, and this will be the spinning angular momentum around the center of mass. Thank you.